All right, today is going to be all about slope. We're going to be looking at slope from a variety of different sources, tables, graphs, equations, and we're going to be using our Desmos graphing calculator. So go ahead and open that up, and let's see if we can't come up with our table values from Desmos. And we're looking for value of y when x is 15 and x is 10 once we get that table. So go ahead and take a minute and see if you can do that. All right, let's see how you did here. So there's a couple different ways that we can approach this problem. So obviously, if I didn't have a calculator and I wanted to use substitution, and I'm going to go ahead and use the 0 just because it's easier. That would go in for my x, so 2 times 0, 3y equals -6, so this would go away, so y would equal -2. So I can certainly do that. Okay, I can certainly do that, which means I can substitute for these guys and see what the answer is. Okay, so I could do 2 times 15 plus 3y equals -6 and solve. But that's kind of a lot of work. And technology is our friend, and time is money. I mean, time is money. So you want to make use of technology to help you as much as possible. So there's two ways we can put this into the Desmos calculator. It will take it as standard form, but it will also take it as slope-intercept form. So I'm going to go ahead and start to solve this for slope-intercept form. So dividing by 3, y equals -2/3 x minus 2. So this is the form that we've been using mostly, okay? So let's go ahead and switch over to our Desmos calculator, and let's put it in. So y equals -2/3, remember to move over, x minus 2, and there's the graph of my line. Okay, there's the graph of my line. Now let's do the same thing, but let's put it in a standard form. See if it'll graph it. 2x plus 3y equals -6. Same thing, okay? Same line. Now, if we want tables, remember how we get tables. We're going to go up to our gear and then click on the table, and there are my values, okay? There are my values. So if I need 10 and I need, I think, -15 were the numbers that I needed. Oh, -15 or +15 and -10. +15 and -10. So let me change that to a +15 and make this a -10. And I have my values. So 4.6 or 4.7 and -12. 4.7 and -12. So this was 4.7 and this was 12. Okay. So definitely lots of options. So go ahead and take a minute and figure out the 4 and the 6 and the -3. All right, so I'm going to go ahead and refresh our memories here. So -3 is 0. And the 4 is -4.7. And the 6 is -6. So definitely easier than doing substitution, okay? So I have a 0, -4.7, and -6. But just because you don't have a graphing calculator or access to the internet doesn't mean that you can't solve this problem, because I can substitute and develop a table. And I can also substitute and find the y values, okay? Because all it's really asking when it asks a question like this is if this is 15 and this is -10, find these numbers. So it's really just asking you for a table. All right, let's talk about slope. So let's start by talking about steepness, Okay, steepness. So these penguins are climbing upstairs. Which one of them is the steepest? And for some of you, steepest might be a new word. If you think about something being steep, that means it is approaching vertical. Okay, approaching vertical. So this one is going to be more steep than this one. And if I was going to ski up or down, or sorry, I guess can't ski up, but ski down, this one would be a lot more fun and I would go a lot faster than this one. Okay, so steepness can control the speed if you're biking down it or hiking down it or sledding down it or skiing. I think if I was going to be climbing, I would want to climb the less steep one and not the more steep one. It'd be a much easier workout. So go ahead and make a decision. Do you think A, B, C, D, or E is the steepest stairs? Which one of these is more vertical? Okay, that's what steepness means, more vertical. Do you have a choice? Okay, let's see how you did. So in actuality, B and D are the same, and C and E are the same. Okay, but we know that this one is actually the steepest. All right, so if you picked C or E, you're correct. But how are those the same? Well, here's how. Let's say this is 4 and this is 2. And this is 2 and this is 1. So if I think about these in terms of slope, I know slope is the rise over the run. So I'm looking at the 4 over the 2. And I'm looking at the 2 over the 1. Now, this simplifies. It simplifies to 2 over 1. Okay, so these are actually the same thing. The same thing. So slope is always going to be a fraction. Okay, it's rise over run. We are always going to simplify, which means we're going to simplify those fractions, look for common multiples, and factor them out. And now let's see what happens when we look at steepness in terms of numbers, okay? Steepness in terms of numbers. So look at the blue lines. So this one has a slope of 1/3. So the dark blue line is 1/3 slope. Then we have 5/7, we have a 2, and we have a 5. Okay? Now, the steepest line is the light blue one. And look at the number. That's a 5. Now, this one is the less steep, okay? Or the least steep. And this has a smaller slope. It's approaching 0. Okay, it's approaching 0. And this slope is getting bigger. So the bigger the slope, the steeper the line. Okay, the bigger the slope, the steeper the line. So if I give you 8x plus 4, that is really steep. But if I give you 18x plus 4, that is not steep. Okay, that is flat. Let's look at these guys. Same thing with negatives. Okay, I have negative 1/3, negative 5/7, negative x, negative 5. The bigger or the farther away from 0, if you want to think about it in terms of distance, the farther from 0 my slope is, the steeper the line. Okay, and it really is an absolute value. So the absolute value of negative 5 is 5. That's a distance from 0. That is going to tell me that that is steeper. So there's definitely a relationship. So you ought to be able to look at an equation like y equals 2/3 x plus 5 and y equals 5/3 x plus 5 and tell me which one is steeper. Well, that one's not too bad because this is a bigger slope. So since that's bigger, it is steeper. Okay? It is steeper. So that's kind of how that works. All right, so let's find slope from a table. And we're going to look for patterns. Okay, so I don't want you to use your graphing calculator. I want you to use your brain. And it's telling us that -2 is -3. And -1, I need to find. So 2 times -1 plus 1, that's -2 plus 1. That is -1. Okay, that is -1. So I want you to look for patterns. So from -3 to -1, I added 2. Okay, I added 2. What happens if I put a 0 in? So 2 times 0 plus 1, that brings me to +1. Look, I added 2. So these are the same. Okay, it's the same pattern. So once I start to see that same pattern, I can actually continue my table without doing any additional substitution. So I'm adding 2, so 1 plus 2 is going to take me to 3. 3 plus 2 is going to take me to 5. Okay, and then over here on the other side, I see the pattern is just +1. Now these values are pretty important because slope is actually found by taking the change of the y over the change of the x. And that's what this delta, which is the triangle, it stands for change, okay? Change or pattern. So the change of my x value was +1. The change of my y value was +2. So my slope is actually the +2 over the +1, which reduces to 2 over 1. So finding slope from a table is pretty simple. I'm just looking for patterns, okay? Now, to be linear, remember, the pattern has to be the same. So I cannot go up by 2, then by 3, then by 2, then by 3. That is not a consistent pattern on every single move. So if it's not consistent, it's not linear. All right, so let's practice this a little bit. So I want you to take a minute. I want you to figure out your patterns, okay? And then try to come up with your changes and your slopes. And go ahead and fill in these missing values. All right, let's see how you did. We're going to start over here on the right-hand side. And I want to double check every single set of numbers here because I have to make sure it's consistent. So 10 to 12, that's +2. 12 to 16, that's +4. Then I have +2. Then I have +4. Well, that's consistent. I can see a pattern, but this is not linear. Okay, it is not linear. So I cannot find a slope. I can find the change in x, that's +2. And I can find a change in y, it's +2 +4 +2 +4. But it is not linear, so therefore I cannot find a slope. If I take a look at this side, -6 to -8, that's subtracting 2. -8, -10, that is subtracting 2. So this would obviously be a -12. So the change in y is a -2. The left-hand side, I see that I'm going up by 3s. So 7 plus 3 is 10. 10 plus 3 is 13. The change in the x is +3. So my slope would be -2 over +3, which is -2/3. Okay, which is -2/3. All right, go ahead and see what you can do with these. All right, let's see how you did. All right, so this one, 11 to 15 is +4. And I'm going to just kind of double check here. How far is it between 15 and 23? Well, that's +8, which makes sense because this would be +4. Okay, so that does keep a consistent pattern. So 15 plus 4 is going to give me 19. 23 plus 4 is 27. So this side is +4. That's the change of y. All right, now, this guy is adding 2. But if I want to go only halfway, that would be +1. So -2 And then I know I'm supposed to be adding 1, so plus 1. Negative 1 plus 1, that's 0. And then it goes plus 2. Is that linear? This one is not linear because the pattern is not consistent. So you want to make sure and double check everything. Okay, double check everything because they'll try to sneak one in at the bottom or on the X side to try to mess you up. So just double check everything. Okay, negative 4 to 1, positive 5. And since there's no other numbers, I know it's linear. That's a 6, an 11, and a 16. This one, we're subtracting 3. So a 6, a 3, and a 0. So I have a positive 5 as my change of y. I have a negative 3 as my change of x. Remember, slope is y over x. Okay, y over x. So positive 5, negative 3. I do not stop here. Okay, I do not stop here because when I simplify fractions, remember the negatives need to go to the top. So the slope is actually negative 5 thirds, not positive 5 over negative 3. Move that negative to the top. We know that that is important because that tells me whether I'm going up or I'm going down. Okay, let's keep going. We've been graphing with slope and y-intercept, but we're going to work backwards and find the equation. And this is pretty simple. You always want to start with your b. So you always find on your y-axis where it's touching. So the b is your starting point. That is going to be a positive 3. Okay, that's going to be a positive 3. And when I'm finding slope, I need 2 points, 2 perfect points, which means I need to find them where they're at the crosshair. So the other perfect point would be here, okay? And here's my triangle. Now notice this is positive slope, okay? This is positive slope. And when we draw, we still want to go the same. That's not positive slope. What am I thinking? That's negative slope. Let's try that again. This is negative slope. So when you are graphing your slope triangle, okay, when we're making our slope triangle, you always want to go up or down first. Okay, up or down first, and then to the right, because that will help you realize your motion. So if I'm at 3, this is going to, since I'm going 1, 2, 3 down, that is a negative 3. And then I'm going over 5, 1, 2, 3, 4, 5. That slope is going to be negative 3 over 5. So the equation is y equals negative 3/5 x plus 3. Okay? And you always want to double check that your slope is correct. So this line is going down, therefore I know that is negative, and that negative needs to be on the top number. Okay? The top number, not the bottom number, the top number. All right, take a minute, see if you can come up with your slope, your intercept, and your equation on this problem. All right, let's see how you did. There's your B. Always start with your y-intercept. So that is 1, 2, negative 3. Okay, that's one perfect point. Now, you might look at this and be like, oh, this one's perfect. Well, that's not as perfect as this one is. This one is a better point. Okay, that one's a better point. And there's also a point right there. And there's also a point right here. So let's compare these triangles. So here's one triangle. Here's another triangle. Let's see what happens. Now, again, this one is negative, so I know I'm going down. 1, 2, 3, 4, 5. So negative 5. 1, 2, 3, 4. And over 4. So this one is telling me my slope is negative 5 over 4. 1, 2, 3, 4, 5. That is also negative 5. 1, 2, 3, 4. They're the same. So as long as I am finding perfect points, I should come up with the same exact slope, okay? Now, if you find You always just want to double check that it's in lowest terms. So negative 5 over 4 doesn't simplify. So the equation is negative 5 force x minus 3, and it's done. All right, now let's look at our last piece here. So the last piece is sometimes I just don't want to graph. It takes too much time, okay? It takes too much time. So we know that slope is the same as rate of change. So that's one thing that you need to kind of get in your head. Slope is the same as the rate of change. So we can find slope from a table. We did that already today. We can find slope from a graph. We can find slope in an equation. Now we want to find slope from 2 points. So we have used this equation, and we've used this equation. The new one today is this guy. And this one is what we use if we have 2 points. Okay, so write that equation down, slope from 2 points. As a matter of fact, if you don't have all these equations down, write them all down and make a note that slope is the same as rate of change. All right, let's take a look at what this process is, okay? So if I am given my equation, y2 minus y1, x2 minus x1, does anybody know what those x1s and x2s might be? Well, if you were thinking that, hey, I have 2 points, maybe they're coming from that, you're right. So this is point number 1, and this is point number 2. So what happens is this is x1, this is y1. This is x2, this is y2. And what I am doing is I am substituting, okay? And it is super important, especially on these types of problems, that you use parentheses. Otherwise, we are going to lose negatives. So we'll really look at it down here where we have double negatives. This one's not quite as messy, but let's lose negatives. And let's go ahead and substitute. So my first point is supposed to be y2. So y2 is 5. So I've used this one. What is the matching number in the other point? Well, that's the 3. Okay, then I'm going to start with x2. x2 is 4. The matching point is the 1. And then I'm just going to do the math. 5 minus 3 is 2. 4 minus 1 is 3. If that does not simplify, then I am done. And in this case, 2 over 3, that is finished. All right, let's try it again. x1, y1, x2, y2. Remember, we're going to use parentheses. And let's substitute in. So y2, negative 6. The matching number is the 4. x2, 5. Matching number, negative 2. So here's where the signs come in handy, where we kind of have to pay attention to what we're doing. So negative 6 minus 4, that's a negative 10. But look right here, what do you see? A negative and a negative makes a positive. So 5 plus 2, that's 7. So negative 10 over 7, that does not simplify. So that slope is done. And slope is going to stay improper. We never write slope as a mixed number. Okay, it's always going to stay an improper fraction. All right, go ahead and hit pause. See what you can do with this next one. See if you can come up with the slope. All right, x1, y1, x2, y2. Here's a negative 6 and a negative 2. Oh, there's lots of double negatives there. Negative 6 and a 3. So negative is positive. So I have a negative 4 and a negative 9. And that is not done. That is not simplified. I need to simplify that. So m would actually equal 4 over 9. It's actually a positive slope, not a negative slope. Special cases. Okay, let's look at our special cases. So we know that we have 0 slope and we have undefined slope. So those are the two special types of graphs we have. And if you remember, this was a 0 and undefined was vertical. Okay, so let's see what happens when we look at this problem. So I have 5 minus a negative 2, and I have 4 and 4. So 5 minus negative 2 is 7. 4 minus 4 is 0. Well, that's interesting, Can I take 7 divided by 0? Can you take 7 of something and break it into 0 parts? Does that even make sense? Let's see what happens if I use my scientific calculator and try to put that in. 7 divided by 0. It says undefined. Well, that's pretty simple because if you think about it, you can't do that. That has to be the undefined line, okay? And if I look at what's really happening there, 4, -2, that's here, and 4, 5, that's here. My line is going vertical, so that is an undefined slope, okay? This one is exactly the opposite. It's going to be our 0 slope. So let's look at what happens there. So I have 6 minus 6, and whoops, 2 minus 4. So I have a 0 and a -2. Well, 0 divided by -2, that's 0. So that one's pretty simple. This is the 0 slope. Okay? So if 0 is on top as you're solving, that is a 0 slope. If 0 is on the bottom, that is an undefined. So watch for when these numbers are the same, because that tells you you're going to have something special, one of those special cases. All right, you should be good to go. Remember, slope is extremely powerful. It is the most powerful part of that equation. It tells us direction and how steep it is. So we need to be able to come up with it from a variety of different methods. So go ahead and practice that today,